Hello everybody, my name is Akshat and today in collaboration with Strawberry Labs, I have built something called as Recipe Hub, which is a web app for managing recipes. I've built this using Python, Flask and SQLite. We'll cover the entire process from code to design. So let's get started. Now, before diving into the implementation of Recipe Hub, I'll just give you a brief introduction about what it really is. So, Recipe Hub lets users add, search, view, rate, and edit recipes. So, we'll use Python for the logic, Flask as our web framework, SQLite for the database, SQL Alchemy as an ORM, WTF forms for the form creation, and HTML CSS for the front end, and Jinja for templating. So, before we dive into the code, let's define our goals. Recipe Hub aims to solve a common problem, that is, organizing and accessing recipes in a user friendly way. I wanted to create a platform where users can easily add new recipes, wherein it's a simple intuitive form for entering recipe details, a powerful search function to find recipes by keywords or just the ingredients name, a clear and well structured display for the recipe, including ingredients, instruction, and an image, a system for users to provide feedback and share their experience, and the ability to edit or delete the recipes that they've already added. So now let us look at how the project is organized. This is a standard structure for Flask applications and it is crucial for keeping your code clean and maintainable. So for the first one, we have app.py. This is where the main Flask application lives, including all our routes and our core logic. Next, we have our models.py, wherein this file contains the basically it defines the structure of our data, like our database models. Forms.py contains the definitions of our web forms. Templates, under templates directory, we have a bunch of files wherein this directory just holds all of our template HTML templates, the blueprint of our web pages. And under the static directory, we store all the static files like your CSS images. We the instance folder directory, we have a database.db file. Now this is automatically created and managed by Flask to store the databases. So this structure helps separate concerns, which makes it easier to understand, modify, and expand our application. Let's open up our models.py. So this is where we define the entire structure of our data using SQL Alchemy. Think of these models as the blueprints for our database tables. Create a SQL Alchemy object. This is our gateway to the database. Okay. So we have our class recipe. This is a recipe model, and each recipe has its own ID, a title, ingredients, instructions, followed by the date posted, and an image which is optional, which can be stored with the file name of the uploaded image. We also have a reviews relationship which links our recipes to the user reviews. We then have a function called average rating. Now, this function is a method which is pretty much self-explanatory. It calculates the rating for each recipe. Finally, we have another class. Then we have a review class. Now, this review class has a rating, an optional comment, date posted, and the recipe ID that connects it to a specific recipe. Now, this recipe ID is nothing but a foreign key which is helping to create a link between the recipe and the rating. So, SQL Alchemy makes it incredibly easy to define these relationships and work with our data as Python objects. Let's move on to forms.py. So this is where we define our web forms using WT forms. So here we have a bunch of import statements, which is basically what it's doing is it's importing the necessary classes and the validators from your WT forms. And then we have created a specific class called recipe form, wherein it is used for adding and editing recipes. So it has fields for the title, ingredients, instructions, and an image upload. Notice the validators. These ensure that your what do you say that your users enter valid data. For example, the data required field. If you have to say over here, the data required field, this one. is mandatory, makes the data required constraint makes a field mandatory. Next, we have another class called edit recipes. This is used for editing your recipes. It has the same fields for the title, ingredients, instructions, and image upload, just like your recipe form. Next, you have another class called your review form, which is just for adding your reviews. It has a rating field with a number range validated to ensure that it is between 1 to 5, and an optional comment field. And lastly, we have a search form class, which is just for searching recipes. So WT Forms handles the tedious parts of form creation, validation, and even security features like your CSRF protection. Now let's open up our app.py. This is the main file, the control center of our application. So we start by importing all the necessary libraries that we need, Flask itself, our database models, our forms, and some other helper functions. Next is the app for the app initialization and the configuration part. What we do is we're creating an instance of Flask and configuring it. We set a secret key, which must be a strong random string in a real application, the database URI. You can do this by using an app.instance path, which for the correct safe path. And we disable our SQL Alchemy tracker for performance. We create our own database tables if they don't exist within an application context. Now let's get to this app.root and the add a recipe function. So this is where we get to the routing part. So each route maps a URL to a Python function, like a view function. So the slash route, what it does is it handles the home page. It retrieves all the recipes from the database ordered by date and renders the index.html template, passing the recipes to it. It also creates a search form for searching recipes. Next, the app road add recipe function. What this does is this as slash add recipe route handles adding new recipes. It uses the recipe form. If the form is valid, we create a new recipe object, save the uploading image using secure underscore file name to prevent any security issues. Add the recipe to the database and commit the changes. Flash a success message and redirect the user back to the home page. Next, what this next function is doing is this route displays a single recipe. The int colon id part is a root parameter wherein it captures the recipe id from the URL. So we use the get underscore or underscore 404 to retrieve the recipe, which automatically returns a 404 error if the recipe does not exist. This route also handles adding reviews using the review form. Next, what this search part does is it handles everything related to searches. It uses the query to search recipes. Next up is your app.root, your edit part. What entirely does is this is used your edit slash int colon id. What this does is this root handles editing. It fills the forms with the data using obj. Next up is your app root.delete. Now this root completely handles deletion. Crucially, it first deletes any associated reviews and the uploaded image file to avoid any database errors. And finally, we start the Flask development server. Debug is equal to true enables helpful debugging features. But remember to set this to false if you're doing this in a production environment. So this app.py file is where all the different parts of our application, the database, the forms, the templates, everything comes together. Now let's see how we present our data to the user. Our templates combine HTML with Jinja 2, which is the Flask's templating engine. Base.html is our base template. It defines the overall structure, the header, navigation, footer that's common to all the pages. Other templates inherit this using the extends base.html keyword. Notice the percentage block. These tags are the placeholders that child templates can override. So index.html, it displays the list of recipes. We use a Jinja 2 for loop to iterate through the recipes and display each one. We use URL underscore for to generate links to individual recipe pages. We handle cases where the recipes don't have an image. Next, moving to the add recipes.html, it shows the recipe form. We use the render underscore field macro easily render each field, including any validation errors. So the add underscore recipe.html shows the recipe form. We use the render underscore field macro to easily render each field, including any validation errors. Next up, recipe.html. This displays a single recipe, its reviews, and the review form for adding new reviews. Next is your search.html. This displays the search results that is similar to the index page. It also displays recipe cards. Next is your edit recipe. This is pretty straightforward. It displays a form for editing your recipe. So this is your underscore form helpers.html, which contains the render underscore field macro. Now, this is a reusable piece of code that simplifies rendering form fields and their error messages. So, Jinja 2 lets us seamlessly blend HTML with dynamic content from our Python code, making our templates powerful and flexible. Style.css is where we define the look and feel of our application. We start with some general resets and styles for the body, fonts, and colors. We style the header navigation. For the homepage, we use CSS grid to create a responsive grid layout for the recipe cards. We add a hover effects for a bit of interactivity. CSS is what transforms a plain HTML structure into a visually engaging and user friendly experience. So, to run the command, all you have to do is type in your terminal python space your file name, which is app.py in our case. This is a live demonstration of the entire app. This is the place where you can add a recipe, a search bar for searching your recipe. So in order to add a recipe, you click the add recipe section in the headers. You can give it a title. Let's give it a random title. Let's say chicken biryani. So you can give the ingredients random. Let's say I'm saying 1 kg of chicken, your all spices, and your, let's say, rice, etc., etc. So you can give any random instructions. You can add a recipe. So after adding your recipes, all of your recipes would be displayed on this home page wherein you can view your recipe and add a review to that. So the users can add a review to all of your recipes that you've already added onto this page, wherein you can have a look at the ingredients, instructions, and also you can edit or delete your already added recipes. So let's say you want to give a rating of let's say 4, and you add any comment saying that uh good recipe. You press submit review. Your review is added successfully. This is from the user side, by the way. You go to the main page and you see that it automatically is updated. The rating has been changed from 0 to 4 along with the date that it's been posted, and you can of course view your recipe. You can edit your recipe. You can add another review if you want. You can comment, so multiple people can keep coming, adding multiple reviews, leaving their comments. And of course you can edit or from the creator side, you can edit or delete your particular recipe. So that's all for today, guys. Hope you've enjoyed the video and you've definitely taken back some gained some valuable insight. I'll be linking this project in a complete GitHub repository which you can find down below. So that's all for now, guys. Thank you and bye bye.